Okay, so today I'm going to explain uh, sometimes that we could use whatever's up there, and there's a relation between integrating the actual function and the inverse version of it, and you could find the integration for the inverse function easier. So sometimes you could use this theorem. So I'm going to prove it first, and then I'm going to show you how you use that theorem. So, but then it has boundaries. So it's if it's for indefinite integrals, it doesn't work. But I mean, same for King's rule that I talked about a few days ago. So it's gonna be the same thing. Not the same, but like it works similarly per se. So I'm gonna prove it really quickly. So we start from the left this time. And then we just say u is f inverse of x. Okay, now obviously when we set the boundaries as well. So now we have um, this, which that's just u. And then, okay, I'm gonna move around things because I don't have enough space. This thing, we could finish it with by parts. These two cancel, so we have BFB minus AF of A. Whoops, handwriting. And I'm going to show you how you use this theorem because it could be quite confusing at times. So this one looks like an inverse function. So we could find the inverse of that, which is the original function. So what's that? Hold on. Okay. So obviously, now we have this. So 4 plus x squared is equal to this. So x is 2 tangents of y. So if f inverse is the original function would just be 2 tangents of x. And then so obviously x is 0 implies fx is 0, x is pi over 4 implies fx is 2. So now we could say that this is true. Um, 0 to 2 is equal to b of fb minus a of fa. This is just pi over 2. Minus tangent x is natural cosine. Hold on, let me check. Okay. So it's cosine 0 is 1, natural log that is 0, and then cosine power over 4 is root 2 over 2. So we just natural log that. So it's and that's it for this first example. The second one is more complicated, but it's literally the same thing. So so let's prove something to y'all so it's clearer. That's just this thing. The axis should be y, so let me change that really quickly. And then x is this. So we want one's y equals something. So 2 over 1 minus x is e to the 2y plus 1. E to the 2y is 2 over 1 minus x minus 1. So y is 1 over 2 natural log of that, which is 2 minus 1 minus x is 1 plus x. So now we find this form, which will be useful in this question because this function is just simply much easier to understand. So now we have this function. That's in the integral, by the way. This function is simply okay, so now we could find the inverse of that. So so again we try to find the inverse function. So and then I believe hold on, let me think for a second here. I believe x should be 3 times 3 times, let me think. Wait, hold on. 9 minus, huh? Okay, 9 minus that. So it's okay. Okay, so if f inverse is that thing, implies the original would be this. So now I think we just try to find the boundaries So when so that would be quite annoying because I don't have my calculator with me. So we'll have to find the boundaries, and I'll suggest this as homework because I forgot to bring my calculator, and I'll call this today. So hopefully y'all will understand how this works.